Hey all, Brad back with another video. This is a follow-up on the Type 1 soundboard. The last video I kind of went over before we did any work, tested it, showed my little Arduino automated tester that had a little shield on top that I built with the 244. Now I'm back about a day later and I've completely rebuilt the board, all the caps, everything on it. I'll go over that and did the mods to prevent any electrical noise passing through the board that they did on the later boards and we'll go through and test it. Also, I'm going to call out Mecca from KLOV Forum. He commented on this that on these pinball boards, there's a little switch um, that switches between chime mode and the regular audio, and I was in chime mode with my tester. So sure enough, I flip the switch and we get really cool Stellar Wars, more space sounds and things like that. They're not just little blips and beeps and chimes on there. So let me switch over to the cam here. So there it is, all reworked on the bench. Um, Again, I'll go over, I return all the parts to the customers. We've got all the old capacitors, Molex headers. There's the bridge rectifier there. We've got a little resistor down here that I swap out. I'll go over that. So all the parts go back on the board here. Let me zoom in. Oops, there we go. Um, So we've got all new electrolytics across the board. We've got a new bridge rectifier here. If you look at the Molex headers here, these new ones have square pins on them, real nice. All the fuses, I go through and pull those out. I do clean them with the actual fuse with the Scotch-Brite pad. Just put it in there and wipe the ends and, make sure the metal's nice and shiny and conductive. And then I have a little pair of curved needle nose pliers like this that I get in and I bend these guys. Not too much. I just take it so you have to put quite a bit more force than when they came out to get them to snap in. So they've got a really good grip. There's a lot of friction on them. You'd be surprised, intermittent connections and things you find on these, arcing that had happened. I did pull both of the 7805 5-volt regulator here, heat sinks, cleaned out the compound with a little alcohol. Did the same thing with the TDA 2002 audio amp, put new heatsink compound in. I can kind of show you here. I have some different types that I use, but this is one I keep in a syringe here. NTE, let's see here. It's called 1 ounce silicone heatsink compound. These things last a long time, and then I just keep them capped, so it stays nice. I have another one I use on the big rectifiers on the power supplies here. This is a HY510, high stability and reliability, apply to CPU, VGA. These really good thermal conductivity on this stuff here. So depending on the application, I have different types of compounds that I run. So both of those on there. And then what else did we do here? Let me zoom back out. So pulled both of the socketed ICs, cleaned and straightened the legs. Um, there was a ton of flux on here. Again, I cleaned all that up really good, both sides of the board, wiped it down. I use I think I've showed this in a different video, but I have these little cloths here. I think they're for like cleaning guns. They're impregnated with silicone, and they do a real nice job at shining up the boards and the ICs, wiping them down once they're clean. So, and the other thing that I mentioned earlier was these amplifiers. Um, I think Williams, they took the circuit when they decided to go with this amplifier. They just took the circuit on the data sheet and duplicated it on this board initially. And these two resistors here, this is bottom one is a 2.2 ohm, and the top one originally was a 220 ohm, and that ratio is 100 to 1. It's basically a shift of the decimal place. And what that does is set the gain for the amplifier to 100. So uh, an amplifier, op amp, audio amp here, their claim to fame in life is they try to keep the output voltage matching the input voltage, but it keeps the same shape or the same waveform, right? So what they do to get amplification is you take the output signal and you run it through a voltage divider. You're basically reducing it but maintaining the shape of it, and then you feed that back in to drive the signal with. So it thinks that the signal it's outputting is lower than the one that it's coming in, right? It's pretty slick. Um, so depending on how much you divide that up, you get more amplification on the signal. And the reality is that um, the digital to analog converter here, On some of these sounds, it's got quite a bit of amplitude, and you end up clipping the signal, but when you gain it up by 100, or you end up operating in an area of this thing where you've just got a lot of distortion. So what I did is put 130 ohm in here, which gives you more of a 60-to-1 ratio. Plenty of gain on the volume pot here still. Just sounds a lot clearer and cleaner. And then on the other side of the board, we found on a previous video I did on a Type 1 that had a really bad hum. I compared the circuit from the early Type 1 to the later Type 2 boards used on the 6, 7 systems, I believe, and of course all the arcade games. And I ended up putting a 1,000 ohm resistor between that audio signal coming in right before it goes through the coupling capacitor here, the AC coupling capacitor. Put 1,000 ohms. So any little stray currents or signals on there that may pick up, this thing will dump it to ground. So it's basically saying, hey, you've got to have a pretty good intentional signal coming over, or I'm not going to pass that through to the amp and let it be amplified. And then the other thing that really solves a problem with the hums is putting this 1 microfarad capacitor. So this top line here, you can see it comes over and it's on pin 1 here, which is your bridge rectifier. So this is unregulated, essentially 12 volts coming over. And then the center pin here, if you trace that back, it's just on the ground plane here, right? So between ground and 12 volts, we've got a 1 microfarad capacitor here. And I think early on, a lot of people, including some of the engineers over at Williams, probably thought that they knew the issue with the noise was due to the power being noisy, so they just kept upping up these capacitors here for the filter cap. The problem is the ESR on these, they're not really good at doing the lower frequency stuff, right? Or high frequency stuff rather. They're really good at low frequency, but not great at high frequency. So you really need that smaller cap with a lower ESR that can capture those quick changes. So we've got that sorted now. I will show you, let me zoom back out here. I mentioned in the other video I had a way to drive these boards manually without my little Arduino. So this is the board. I've built this years ago, just a little prototype board with a dip switch and a momentary button that I can send over all the bits simultaneously, ground each pin essentially. So let me power it up and I'll drive a couple manually, and then we'll go through the automated tests. So I think I'm in chime mode right now. So basically these are the bits across the top here. Let me zoom in. So this is bit 0, which is 0 or 1, and then we have 0 or 2, 0, 4, 0, 8, 0, 16. Those are the ones of interest for this. That's all it goes up to. These ROM on here, you get 31 inputs essentially. 0 through 31 gives you 32 discrete, and they're not using 0 here. So here's bit 1. That's in chime mode. And then if we want, I'll flip the switch over to the audio mode, the fancy mode. I'll mention too, on last video, I was using a kind of an open frame speaker. I went through my stuff and I had this old Bose little speaker that's kind of enclosed. It's a little nicer. Actually, you know what? I'm going to switch over and mute my mic on my headset and switch over to the one on the webcam that's filming the bench, because I think. Okay, should be picking that up a little bit better. And then I can just. So I'm just manually triggering some of these. So what I'll do now is I'll switch over, take that out, and we'll put back in the my little Arduino tester here. And then we'll apply some power. This is just 5 volts coming in. We could power it via USB, but I like to have the grounds tied and all that, so I'm just using the same power supply. Okay, now I'm going to flip the switch over back to chime. This is essentially the same thing we did in the first video, but just to see the difference, I'm going to reset this. Okay, so the one question I know I'm going to get in the comments is probably why did they have that chime mode? Well, Mecca commented on it. I speculate that at the time, in the late 70s and that most of the machines in these arcades were, EM mechanical. They had dings and bells, physical, chimes like that. And either these games sounded out of place, and some people may have wanted the similar sounds. But to be honest, I'm not sure. I haven't looked into it yet. I haven't, tried chat GPT or anything asking, but I'm just speculating. So if you do know for sure, put it down in the comments. I can pin it, or we'll go from there. So anyway, this board is all set, and I'm gonna. It ran 24 hours already under the automated testing with the volume turned down low, actually, and I'm gonna get it boxed up with the old parts and going back to my customer Brian. So thanks for watching the video.